Important characteristics of wave motion. 1. Wave motion is a kind of disturbance traveling in a material medium with certain fixed velocity. 2. In a motion, there is no transfer of the particles of the medium from one part to another part of the medium. The particle of the medium execute vibratory motion about their mean positions. 3. The disturbance or wave motion from one particle reaches the next neighboring particle a little later, and as the disturbance reaches, it also starts executing vibratory motion about its mean position. 4. The velocity of every oscillating particle of the medium is different at its different positions in one oscillation, but the velocity of wave motion is always constant. That is, particle velocity varies with respect to time, while the wave velocity is independent of time. 5. For the propagation of wave motion, the medium must have the properties of elasticity and inertia. 6. During the propagation of wave motion, energy is propagated from one part of the medium to another without any actual transfer of the particles of material medium. 7. The net displacement of an oscillating particle is zero over one complete oscillation. Important points. 1. A mechanical wave shall be transverse or longitudinal depending upon the nature of the medium. Made of excitation of vibration. For example, in solids, both transverse and longitudinal waves can propagate. This is because solids can sustain both the shearing strain as well as compressional strain. On strings, mechanical waves are always transverse. Gases can sustain only compressional strain and not the shearing strain. Therefore, only longitudinal waves can pass through air and other gases. 2. The waves on the surface of water are of two kinds, capillary waves and gravity waves. The capillary waves are ripples of short wavelength, a few centimeters. The restoring force that produces them is the surface tension of water. The gravity waves are the waves of long wavelength, several meters. The restoring force that produces these waves is the pull of gravity, which tends to keep the water surface at the lowest level. The waves in an ocean are a combination of both longitudinal and transverse waves. It is found that generally transverse and longitudinal waves travel with different speeds in the same medium. Speed of transverse wave motion. The speed of transverse waves in a solid is given by V equals to square root of eta by rho, where eta is the modulus of rigidity of the material of solid and rho is its density. The speed of transverse waves in a stretched string is given by V equals to square root of T by M, where T is the tension in the string and M is the mass per unit length of string. If R be the radius of the string and D the density of the material of the string, then M equals to volume per unit length into density equals to pi R square into L into D. Thus, the speed of transverse wave can also be expressed as V equals to square root of T by pi R square D. Speed of longitudinal wave motion. The speed of a mechanical wave in a medium depends only upon the properties of the medium, but not upon the amplitude or shape of the wave. The properties of the medium controlling the speed of the wave are elasticity and inertia. Newton proved theoretically that if the modulus of elasticity of a medium is E, and then the density is rho, then the speed of longitudinal waves in the medium is given by the expression V equals to square root of E by rho. Equation 1 is the general expression for the speed of longitudinal waves in material medium. The speed of longitudinal waves in a solid block is given by V equals to square root of B plus 4 by 3 eta by rho, where B, eta and rho are the values of bulk modulus, modulus of rigidity and density of the solid. In case the solid is in the form of a long rod, the speed of longitudinal waves is given by V equals to square root of Y by rho, where Y is Young's modulus of material of the solid rod. The speed of longitudinal wave in a liquid is given by V equals to square root of B by rho, where B is the bulk modulus and rho is the density of the liquid. The speed of longitudinal waves in a gaseous medium is also given by equation 4, where B and rho correspond to bulk modulus and density of the gas, because sound travel in the form of longitudinal wave in gases. The equation 4 also given the velocity of sound in gases.